Hello everyone, it's Peter. Welcome you back. Today we will go to the multi-threading, another big topic. Before that, I think last time I left an important topic not covering, that is deep copy through serializable. So we talked about serial copy through the prototype with clone and clonable. Now with serializable, we can make a deep copy. Let's make an example. So last time we defined person. So we use transient keyword for the name. So now I just come back to the normal serialization without transient keyword. I just delete this transient keyword. Okay. So this is a normal person. All the fields will be serialized. Okay. Now let me make a test. Class deep copy test. Okay. Now let's make a deep copy of the person. Deep copy. The input is another person. Okay. Now, what we do is I return a person. Result equals to null. First, I remove the compile error. Then I use try catch block. So I will use let's see try. I use byte array output stream. Output stream, just output new byte array output stream. Okay. Import l.io.star. Now, then it's object output stream. First, I move to this OS equals new object output stream. Okay. Now I can write object for this person. So this is then next I use byte array input stream. And inside output stream the 2 byte array, let's use this one. So here I add an output. Now result is also the object input stream or new object input stream. And now I get result equals to person dot read object. Catch exception. So I just print out something. Okay. So this is a deep copy. Now let's make a test. Test deep copy. So now first I make a person. Do I have a constructor? I don't have a constructor, so I just make a person equals new person. Person dot set ID. Person dot set name. Okay. Now I use deep copy. Present another equals to deep copy of present. Now I can compare them. Equals to another dot get ID. Present dot get ID. Okay. Assertions. Now this is get name. So this should be no problem. The most important part is the get name is not the same name. So assertion star assert not same. Another dot get name. So their reference is different, but their value is the same. Now let's make a deep copy. Okay. So you can compare this one and our clonable. If I move to the test of the clonable, let's which is that clone, yeah. You can see like employee. So we get name, get ID, name, salary, and EMP is not the same, but the get name is the same. This is a shallow copy, right? This is a shallow copy. Now in this one, this can prove this is a deep copy of person. Yeah. So its fields are also different. The references are all different. There's no same different reference. The value is the same, but the shallow copy here, the field reference is the same. If the field is an object, this is shallow copy, and this is a deep copy. So when we talk about the shallow copy and deep copy, then clone and clonable is the way to do the shallow copy, and serializable is the way to do the deep copy. That's another important question which may happen in the interview. Okay, now we finish up with the I/O. Okay, now let's go back to the multi-threading and concurrency. This is a big topic. I'd like to give some important concept, but I won't move very deep because this is huge. So I may spend another 10 hours to talk about the multi-threading, but I just cover some important topic which can be covered in the interview. Okay. Let's first understand what is a thread. Thread is a class. Okay. So if you create an object of a thread, number one, this is an object. First is object. It satisfies all the features of object which we covered before, like OOP concept. Everything is the same like object, but it has a different feature, like it can create another thread. Okay. Now, what is a thread? So let me use a simple example. Let's use this one. Suppose I have class A, extends threads. Extends thread. In the thread, you need to override run method. Run. I just print out the line. A thread of A is running. Okay, a thread of A is running. And then because I want to clarify which is the thread name, there's a method called thread dot current thread dot get ID, something like that. I didn't quite remember. Okay, maybe let me think about that because there's no hint for the method. Let me come back to this one. Okay, let me still use this one to do that. Let's say new package thread. Now, new class my thread. Then the superclass is thread. Let's run this. Okay. This is not mandatory, but if you want to extend thread, you always need to override the thread run method. Otherwise, it will use default run method, which get nothing, right? Override. It's only one method called run. So now let's move on. So then we print out thread dot current thread dot get a name. So for each thread, it will automatically give you a name unless you create a thread with a parameter. Okay. Then plus a thread of my thread is running. Okay, just print out this line. Now I use main method. I do something. Okay, first I create my thread. I can use refactor. I give the wrong name, rename my thread. Okay. Now, first thing is I run my thread.start. Then I run my thread.run. Then I print out end of main. End of main. So to prove that this run can still working and it's the same thread as end of main, so I still add this one because this can show what's the thread. Main is also a thread plus end of main. So let's run it. Okay, now you can see that my thread.start it create a thread called thread-0. This is thread name. This is by default. The system will give you a thread name unless you you set a name for that. And then you can see the run is in the main method. The system out, this is end of main is in the main method. So there are two main methods, there are another thread. I see this. Okay. So this means what? A thread, my thread is an object of thread. Number one, it is an object. Run is a method inside this object where I can call the run method many times. There's no problem. But I can also call start method. The start method will also call run method. It create another thread. Okay, so here is a very important concept. A thread is first an object. It has all features of an object. Like a normal object, you can call any method, like run, even the run method. Right? Then to start a new thread, we must call start method from top level thread class. You know, we don't have the start method ourselves in the main thread. So it means that the start method is inherited from the parent thread. And then after start method is called, it will create a new thread. It will create a new thread, and the new thread will call run method. So it means that the start method will also call run method, but the difference is the start method calls run method, it will have a new thread. But if you call run method directly, then this is from the main thread. It's from the main thread. I want you to clarify the difference between start and the run. Then next, Runnable. Runnable is an interface. Actually, if you see, check the Java thread class. So thread class itself implements Runnable. Okay, so top level is Runnable. The Runnable has only one method called run. So Runnable is an interface. It has only one method called run. It means what? We can use the lambda function, right? We can use the lambda function. So let me do this. So how to make the run method? I just run here. I don't have to. Yes, I can write a class. Say class A implements Runnable, and then I override the run method. Right? I can do that. Make an inner class or make an outer class, doesn't matter. Implements. Then here it asks you to input a method, and after Runnable is created, I need to place this Runnable object inside an object inside a thread. So what I do is I need to have new thread of new a dot start. Still we need to call start. Okay. Now another way is I don't run this class. I don't write this class. I can define a Runnable directly. Runnable, some Runnable. This is another thread equals to new Runnable. I talk about the anonymous in the class. Then you override run method. You can print out something here. That's another way. And then I can new thread, then another, then dot start. That's another way. Okay. Now, because we talk about lambda function, I use an easier way. I even don't need this. I just say new thread. Use this way dot start. That's this. So can you see this? This means that inside new thread, I have an anonymous inner class, which is using the lambda function as a runnable. The runnable has a run method, only one method. There's no parameter. I just use empty parentheses and then use an arrow, then write the code. Then I can print out print. I still use this one. A runnable thread is running. Okay, just run this. Here I should have three threads. One thread is from my thread. This is run method. The second thread is main thread. Right? I use run or use system out. And then I have a third thread. This is a new thread with a lambda function and a called runnable method. Let's do it again. The main thread of my thread is running, right? And then thread 0, a thread of my thread is running. And thread -1, you can see there are three threads. So I use the thread.current thread.get name. I give the thread name. A runnable thread is running. This is runnable. So typically saying every thread is runnable because the thread implements runnable interface. So you don't have to really write a thread, but you can use new thread of a runnable to start a thread. So from this example, you need to understand the difference between the thread, runnable, and the run method. Anyway, the important point is you have to call start method to start the thread. Without start, it's just a normal object. It's just a normal object. No matter it's runnable or or thread, there's a normal object. Only after you call start method, it will start a new thread. Can you call start method twice? Of course not. You can try it by yourself. For example, if you call my thread.start twice, it will have an exception. Because when a new thread is a new thread, so my thread becomes a new thread. But you call another start, my thread plays another thread. So one object can only play with one thread. It cannot play with two different threads. So this one will have an error. I don't want to test. If you like, you can test by yourself. So here I'm trying to explain what's a thread and what is a runnable. Now, what is a daemon thread? Daemon thread, like our garbage collection, is a daemon thread. And give a definition. Daemon thread is a thread that will be stopped by OS if all main thread are finished. So Daemon Thread is how to describe that? It's some thread which is in a background running, or from our user point of view is just hidden. We cannot see that. We cannot see that. But when all the main thread is finished, main thread means that the normal thread, like in the main thread, we may have also have this. Like, let's come back to this example. In this example, when we run the main method, it has 3 threads, like main, thread 1, thread 0, thread 1. There are 3 threads, but actually there's a daemon thread as a garbage collection. So some people may ask you in the hello world, how many threads are working, are running? Actually, there are 2. It's the hello world, that's the main thread, and another one is garbage collector. And this one has 4 threads. 3 of them are in the main thread, like main, thread 0, thread 1, and another one is the fourth one is garbage collection. This is called daemon thread, just the concept, a daemon thread. So, including garbage collection, what kind of thread could be a daemon thread? We can say like an event listener. Right? Event listener is very passive. It's just a thread running here, waiting for some event to happen. So event listener can be defined as a daemon thread. So a thread has a method called, you can say there's a method called set daemon. Let's say super dot set daemon, right? By default, daemon is false. If you set daemon to be true, then this becomes a daemon thread. So this is the method to call that. Right? Now, let's move on. Next, we talk about the thread. If 2 threads they want to get the same resource, we have a synchronization. The synchronization can be at the class level or object level. So to understand the synchronization, I give a concept. What is the synchronization? Synchronization is a way to make threads running in an order without overlapping. That's the basic idea of synchronization. Let's think about this. So you have multiple threads. The multiple threads may get or set access to the same resource. So they may have some confliction. So like an int value, one thread may want to change it, and another thread want to update it. So what can we do? So sometimes we may get the legacy data is not the latest data, and use synchronization can prevent these things. We in our usual terminology, we say, oh, I want to run something asynchronously. There's an asynchronous. Simply asynchronously. Async means they can run at the same time, and sync means they cannot run at the same time. Now, let me give you an example. Let me give a very simple example. I write another class, new class. My sync class. Okay, my sync class. Okay. I have 2 methods. Like I have private intx. So I have a method called get and setter. This is getter, this is setter. Okay. Okay. Now let's make a test. Okay. So first class, I have object equal to my sync class. Okay, dot set x, say 100. Now I launch two threads. One thread is to get x, one thread is to set x. New, okay, new thread. I use this one. Okay. This one is obj.setx equal to 200. Start. And then new thread. So both there are two threads. Both of them are, one is used set, one is used get. Read x and get obj.getX. Okay. So when the threads are running, so it's hard to say which is going first, which is going second. So this read x will be the read 100 or will be read as 200. So we don't know. Yeah, what's wrong? Oh, static. This is 200. Let's run it again. For multithreading, it's hard to test. So if you change the order, because setter is slow and get is faster, so maybe it's only use getter. Now, to make some change, let's make a delay. Okay, private static void delay. Delay millisecond. Is use thread.sleep. I don't have to do anything. So for the two thread, I make a delay. Delay random number. Let's say okay. Just make a test, and then the first one I delay a random number dot next and like 100. The second one I also delay with 100 delay some random number. So it means I don't know which is first, which is second. So in this case, it's hard to say. So I can run it. First, I read x. It should be 100, right? And set x to be 200. But if I run multiple times, see now this read x is 200. It's 200, 100, 100, 200. Right? You can like this test. So it's hard to control which one is first, which one is second. And I just want to use synchronization to do that. But this synchronization will not really help the code thread safe. For example, my code flow is read first, then write second. Read first, then write second, right? Then if I use synchronize keyword, Will that help? Actually, I will say it's not help. And the synchronized keyword means what? So it means that when one thread is reading is called getX, another thread cannot call getX, cannot call setX. Or if one thread is called setX, another thread cannot call getX. If I run it, you can also see the two numbers may happen. Yeah, it may not happen. The reason is with delay, you don't know which goes first, which goes second. It's not easy to control. So it means when I delay more seconds in the first part and the delay next second in the second part, so setX will go first. So when we call getX and the getX cannot work. When the first thread call getX, the second thread setX cannot work. Yeah, that's the meaning of synchronized keyword. Okay. Now, the test currently is hard to create a good test for synchronization, but I give an example. I'll give a definition of the synchronization. There are two levels of synchronization. One is the class level. Class level means that when a method, a static synchronized method called the class lock is obtained, and no one without the class lock can enter this method. Yeah. And the object level, when a non-static synchronized method is called, the object lock is obtained, and no one without the object lock can enter this method. Right. Now here I give an example. A good example like this. Let's say class A. So I have four methods. Public, synchronized, void, foo1. This is one method. Foo2. This static foo3. Then this is also static foo4. And then void foo5. Now the question is, let's say we have an object of A, and two threads, T1 and T2. Now, the first question is, can T1 and T2, can T1 access A.foo1 and T2 access A.foo2 at the same time? Yeah, this is the first question. So we have object of A. I can create like A equals new A. Now we have two threads, T1 and T2. Like what happens here? There are two threads. They want to access an object of my synchronized class. Okay. Now, if T1 accesses A.foo1 and T2 accesses A.foo2 with different methods, can this happen at the same time? The answer is no. The reason is when a of 1, when T1 access a of 1, T1 will get ace lock. When T1 access a of 1, T1 gets ace lock. This is object level lock. Okay. And when T2 access a of 2, it also requires ace lock. Okay. But the ace lock is already obtained by T1, so T2 has to wait until T1 is finished and release this lock. Then T2 can get this lock and go ahead. So it means that T1 access a of 1 and T2 access a of 2, they cannot happen at the same time. Now, the second question. I use same way, but I use a of 3. So T1 access a of 1 and T2 access a of 3. 3 is a static method. Can they happen at the same time? The answer is yes. So actually, small a of 1 is actually equal to a dot for 3. Small a dot for 3 equals to a dot, capital A dot for 3. The reason is this is static method is class level. So what happens is when T1 accesses a of 1, T1 gets ace lock. This is the same statement, no problem. But when T2 accesses a of 3, it gets ace lock. This is the class level lock. So you get different locks. Ace lock, object level, and capital ace lock is the class level. There are two different locks. That's why they can do, one is going to F1, the other is going to F3. They can happen at the same time. There's no problem. Okay. Now, the third question is, can T1 access a of 3 and T2 access a of 4? One access a of 3, one access a of 4. Can that happen at the same time? The answer is no. Right? The reason is both of them will get the class level lock. There's only one class level lock, so that's one will be excluded from another one. Yeah. So I think this, after you understand this will be clear. And then the next question is, can T1 access a of 1 and T2 access a of 5 at the same time? One access a of 1 and the other access 5. Then the answer is yes. The reason is when T1 access a of 1, T1 get the object level lock. But when T2 access a of 5 is not synchronized. It doesn't need any lock. It can enter the method directly at any time. Right? So if you can answer the 4 questions, then it means that you understand the different levels of locks, the class level or object level. But now, if I want to design a code to prove that, it's very difficult. So I would rather say in the multi-threading, the code proof is very difficult. We need a very detailed, we should be very careful because lots of things is hard to say. But theoretically, I can give you an explanation. For example, let's come back to this example. People say, okay, I want to make a class thread safe. How to do that? People would say, oh, I just synchronize all the methods. This doesn't work at all. Okay? Be very, very careful. Multi-threading is depending on the situation. It doesn't mean that synchronization can make your code thread safe or make your class thread safe. That's not the way of multi-threading. That's I should say this totally misunderstanding of multi-threading. There are lots of ways to make the class thread safe or to make your code thread safe. A class thread safe doesn't mean the code is thread safe. For example, we talk about some collection framework. Let's say, let's come back to some APIs like this. Okay. We talk about something like array list and vector. Okay, array list and vector, they have different resizing rate, but another big difference is array list is not thread safe and the vector is thread safe. Vector is thread safe. This means what? This means that at one time only one thread can access the vector. This just means the class is thread safe. It means inside the vector, the methods are all synchronized. It can guarantee this class is thread safe, but it cannot guarantee that the code is thread safe when you use this thread safe class. That's two different things. Okay. And also like string buffer and string builder. String buffer is not thread safe. String buffer is thread safe. String builder is not thread safe. Okay. But thread safe has a bad thing. That is, thread safe class has worse performance than non-thread safe. For example, like vector and array list. We can assume if 100 threads are accessing array list to read some object from the array list, and another 100 threads want to access vector to read from the vector, who has better performance? Then definitely it's array list, because array list is not thread safe. It means 100 threads can access a get method, get some index at the same time, but vector is not. So 100 threads has to use get index one by one sequentially. That's why array list has better performance. So remember that synchronization always lead to a thread safe things, but will get the worst performance. So in the real project, we prefer to use non-thread safe classes like array list, not or string builder, not string buffer or vector. But if you really face some thread safe issue in your code, then it depends on different situation. You can use different strategy to design your code to make thread safe. Like even if you use vector, this class is thread safe. It doesn't mean your code is thread safe. Always remember this. This is very important. A class thread safe doesn't mean when the class is used in your code, the code is thread safe. That's not the same thing. So for thread safe code, you are not care about the thread safe class. You care about your code is thread safe or not, right? So that's why you only need to design some good things to make your code thread safe. That's another big topic. Okay. So in this class we give a brief introduction of thread, Runnable, Daemon Thread, and synchronization, and with different levels. Okay. Next class we talk some more topics, and I think I want to use 2 sessions to finish up the multi-threading part. Okay. That's it. Thank you.